Hello.
Hi. Good morning, Ali.
Hello, Ronan.
Hi, Radek. Good morning.
I think we have a full come here. Let's start. Last week, I was I had a discussion with Yinxin and Sam regarding to the Anoat implementation, Anoat tree implementation, and also spot a failure when Crimson OD tries to shut down, it failed to do so because a free before referencing issue, which was fixed last couple days ago, and aside from it, I also spotted a memory leak caused by Anoat. Somehow I failed to record it. I will continue looking at it, and
What,
apart from
what
it,
do you
I
mean
will
by Anoat
you.
memory leak?
Oh, sorry. It's if you enable if you build Chrome with ASN or with a CMake build type equals debug, you will enable ASN, and when Chrome shut down, ASN will identify a leak because a node info was not properly released somehow. I could paste a
Oh, okay. Thank you.
backtrace
So
in the
it
page
is for
later
18
on.
plus now?
No, not really. I was testing using CNStore.
Okay.
So that's it. I'm done.
Hi. Can everybody hear me? Okay. Good morning. So since last week, I was focusing on the open pull requests. I saw your Jeff and Radek. It seems like the CVT pull request is ready to be merged, I think. Thanks for the title change, Careful. Greatest venture YAML. Also, I've made some progress with the debugging of the object class with execute OSD ops. It's still not ready, and this is what I'm going to be working on all day today, trying to figure out what the problem is. It's just that this was pretty much my first time getting familiar with some of the Crimson source code. So I was still learning pretty much everything, or pretty much Ceph source code in general. So yeah, that's pretty much what I'm going to be. The plan for today is heavily focusing on that, and that's pretty much it.
Yes, Anna. I will take a second look at your CPT PR.
Okay, thank you.
No problem. May.
Hi. So last week I just read some document and papers, and I noticed you guys discussing the fixed key for the B plus tree. So I found some presentation here. I pasted here, and it introduced some key compression and key shared prefix and suffix traction. So I think if we can get how to implement the B plus tree support the variable key, then we can use a common algorithm for all of the B plus tree in our code. So it is introduced some method for common prefix, shared prefix, and suffix traction, and some method key compression. And they treat the key B plus tree as a string. So I think our key is a long string, right?
Sorry, what are we talking about?
Talking
The Anoat tree?
Anoat tree, yes, Anoat tree. How to support the variable key, variable
No, we're
size
specifically talking. So I think people would benefit from going back and reading older papers on database indexing. I can try to put some of those together, but the short answer is no, you don't have to treat them as a string. For instance, if you're constructing a database or a database index purely on, let's say, a 4-byte integer, then you can store that, you can do comparisons on keys using integer operations. You needn't do string comparisons. You know they're 4 bytes long, and you have processor instructions, even simmed, for doing comparisons quickly. So the first 4 components of our key tuple are in fact numbers. So we'll try to exploit that as much as we can. If you're talking about BlueStore, yes, BlueStore turns everything into a string and does it that way. It's one of the major reasons why BlueStore is slow.
Oh, okay. So we treat the key as the integer?
Have you seen the Anoat Redesign?
Yes.
I'm pretty sure I shared it with everyone. Okay, so the very beginning of that document has a page or two explaining why the key is what it is. Did you
So
read
you
it?
mean the Anoat tree should know the key format partition, which part is per ID, which part is crash hash?
Oh yeah, for sure. Yeah. This isn't meant to be generic. We're going to exploit all of the internal structure that we can.
Oh, I see. Okay, I got it. Thank you. Okay, no much update from me.
Thanks, Jimmy. Redek.
Not much for Crimson since last stand-up. I was mostly focused on the GCM stuff and some bugs on it for Octopus.
What? Sorry?
From Crimson,
What did you say? On
GCM,
what?
AES GCM, on crypto stuff.
Okay.
For Crimson, I reviewed the 2 PRs from Avnum about CBT. They look good. I asked Mark Nelson for final look. Also, Crimson is also Octopus is out, so I think we can safely merge the two to CBT. It's quite important because it's used on tautology, and we wouldn't want to break it before Octopus. That's me.
Brennan.
Hi, everybody. I have a new office now at home. So the background is now a new one. And by the way, I don't know if you know, but we are here under lockdown for all of Israel currently. Not allowed to go more than 100 meters out of home. So yes, it does give me more time to work. I don't have to travel to work. So I started writing actual code in Rubbing. I probably have more questions for you, for the team, in the near future, the next few days. But that's more or less where I am now.
Okay, Sam Brennan. Sam?
Yep, I've been mostly going back and forth with Dingzhen on the Anoat Redesign. I think we have 3 pretty well thought out concepts here, so I think we should discuss this a bit towards the end. I think we're making progress. I think all of these essentially address the problem of ensuring that we can do that we can, in the event that the crush hash does a good job, we should be able to find the key we need without doing any string comparisons. We'll also have to do 1 string comparison at the end to make sure it's the right one, but that's unavoidable. So I think that's the really important property, so I'm happy there. The rest of this, I think, is further discussions to decide what we want to do for a prototype and then go for it. Aside from that, I'm continuing to work on the LBA tree. That's it.
Thanks. Shahan.
Last week I was modifying my fix for the peering issues that came up during the debugging of the ptlog-based recovery, and I think now all the known issues has been fixed by now, and I've started from Monday that to truly debug the ptlog-based recovery, and that's it for me.
Okay, last week I spent most of time at the Anoat tree design, and so the progress of heartbeat fix is not. I still need some effort to work on the heartbeat issue. That's all.
Okay. Do you have any other question or comment?
You might want to know the email Josh sent regarding organizing the work. A few you had sent something some hours ago regarding a Twilio board for Crimson.
Oh yes. Josh suggested that we might want to switch over to use Trello to do planning. How do you think? Currently, we are using the Kanban offered by GitHub. So after October, we might be able to put more guys into the development of Crimson.
I don't have much experience with either. If people have a strong opinion, that seems fine to me.
I don't have a strong preference to adopt them as long as they work.
Do you mean after the release, there will be more people join the Crimson project?
There's a basic assumption that, so as recovery starts to work and we start to have a basically functional OSD, it'll become a lot easier. People will start working on integrating it into Ceph ADM and integrating it into deploying tools, working on features that are missing. That'll all be a lot easier once we have a basically functional OSD. So yeah, probably over time, the number of people working on it will increase. If that makes sense.
Yes.
What about the effort necessary for conversion? I mean, now we use GitHub Kanban. Moving to Trello, if there is put some extra work. Is it worth?
I would like to preemptively time-bound this discussion to 5 minutes, just for the record. If people are okay with that. Yes, there is a conversion effort. It would take work, but we don't have that much stuff in GitHub, so I don't know. Yeah. I'm not entirely. Does anyone have a good sense of why Josh wanted to move?
No, I don't.
So if you read the least bad option, that was the definition.
I mean, that was the assertion.
Yeah, I will.
I'm not sure why that's true.
Yes, I will reply Josh. And
GitHub has exactly one property I think we should weigh heavily, which is that all you need to use it is like permissions on the GitHub repo, which are already a necessary property for contributing. So in a way, we've already solved that problem. I don't know about Trello. Maybe it's also easy. But I suspect that we would have to permit people to modify the table separately.
Well, I can't for now see the table, which should have been public, so it's not automatic.
I think the advantage of current GitHub project is that some parts are automatic. You can link the project directly to the PR. So I don't think
with
Trello is
with the Crimson label as well.
Yeah, that's true. I do like that. That is nice. It might be worth asking why he wants to switch. Yeah.
Yeah, I will put all the facts on the table and discuss with Joy and team to understand why, to figure out what the route we will take, and keep you guys updated. Any further questions or comments? Okay, regarding to the Anoat Trade implementation, we can follow it up on the Google Doc. I paste over the chat. See you next week. Have a good day.
Wait. I thought we were going to discuss
Sorry.
it. Can we discuss the? I thought we would discuss the Anoat Redesign.
Okay, cool.
I was just trying to time down the talking about GitHub part, not the whole meeting. Sorry. Those discussions can go on for a really long time. Anyway.
Yes. Do you want to continue this discussion over the stand-up regarding to the Anoat Trade implementation?
Let me see. I might have, at least one hour of the next meeting, one or 2 hours. Yeah, sure.
I mean, at this moment, do you want to continue discussing on the tree? Okay.
Sure.
Go ahead.
I'm a little under the weather yesterday, so I only skimmed over the your design, Sam. Your flexible layout fixed tree problems. I think I still with you because if we can use the fixed parts for the first one levels, that's a big win, and we can leave the trouble at the bottom half if we have to pay the tax for it.
Well, okay, so I guess I wanted to lay out a couple of sort of fixed points for how B-trees work. So who here is super familiar with how who here is not very familiar with how B-trees work internally? We're all on the same page?
I'm kind of.
I can't say I remember everything by heart. I learned it, but.
Okay, so like any tree, what we're doing is we're recursively partitioning the key space, right? Is that is that a terminology, or should I try different words?
It's okay.
Yes, I think it's okay.
So any particular node represents a subset of the overall key space, ordered the way we've chosen to do ordering, right? So based on how the node's parent has its pivot set, that is the keys on either side of this child, this node is responsible for all values keyed by a key between those two values, right? So for any node, we can speak of the lower bound and upper bound for its corresponding subtree. So this entire design is based on one observation, which is that if the lower bound and the upper bound share a prefix, we can omit the prefix.
Sam, do you need to share the document?
This is the same document we've been looking at the whole time. We're on page 12. Yeah. Flexible layout fixed tree. It's at the very bottom.
Okay.
So the idea is that if a particular node, and therefore all keys in the subtree that it represents, share a particular prefix, we don't have to include that prefix because we know what it is, right?
Yes.
Everyone with me on that point?
Yes.
Yes.
Okay.
Yes.
So the entirety of the design is that we designate 4 different kinds of node. The first kind of node has the entire key. It has the shard, the pool, the crush, and the right side, the shard, the pool, and the crush hash on the left side of the node, and the namespace, the OID, the snapshot, and the generation on the right side. However, as we descend the tree, and this should happen at almost the next level, because it's basically never going to be the case that we have more than a few pools, right? So by the time we get to the next level, we shouldn't have everything in one of those nodes should be the same pool. So we can omit both the shard and the pool, leaving us with the crush hash on the left side. This will be true for most of the internal nodes. So for most of the internal nodes, we just have on the left side of the node a fixed size vector of crush hashes. This allows us to do very efficient lookups. Everyone with me so far? We're just looking for a number in an ordered vector of numbers.
Yes.
Cool.
Sam.
Yep.
For example, how do we look up a given prefix? Because if we want to compare the fixed part of the name of the object, we still need to look up in the right part of the internal node, right? To understand the prefix.
Interestingly, no, you don't. So if you're at an internal node and you know your crush hash is I,
yes,
and you find two adjacent entries on the left side of the node, one is less than I and the other is greater than I, you're done. You don't have to look at the right side at all. Right?
Because we store the pool ID and the hash and
it's because there is no possible
in the left
value.
side of the.
Yeah, well, in this case we're not even storing the shard in the pool because we're far enough down the tree that they're not relevant anymore. So it's only the crush hash we're looking at. And if we see two adjacent entries where the node we're actually looking up is between them, then we know there is no possible set of the suffix that could possibly change the answer.
Okay.
Which is the key to the second observation, which is that when two adjacent children don't share a crush hash, we don't have to include any of the suffix elements on the right side. It can be empty.
By then, we already know the hash part of the OID.
Right, because we've been clear on that one. With the n equals 1 node type here, the left side of the node is a vector of crush hashes. So the only time the right side would have anything in it at all, other than the child address, that is in the event that two adjacent entries have the same crush hash. See what I mean? Otherwise, there's no reason to include the right side at all. So you just drop it.
But you probably want to mark the fact that you don't have a right side.
Actually, you can infer it. The fact that the two are different means you don't even have to do that. However, yes, if you want to, on the right side in the variable section where you have the value, you could have a 1-char prefix to that variable size portion that indicates which fields are actually present, and that will be necessary for compression. But it only costs 1 byte, yes. And it's only on the variable size part. You only look at it if you're actually going to do the lookup, or in the event that there was a collision and they actually differ by strings. In that case, you literally had to look at the strings. There is no optimization that will save you from that part.
Okay. Apart from having an extra, adding an extra hash, that's not part of the heart of the design. But you can add, you can prefix the string with a different hash for the string.
The only reason you would do that. The only reason you would do that is if the number of objects is too large for the 32-bit hash we already have to do a good job. Which could happen. Earlier in this document, there is a table that indicates the conditions under which that might be true. But we wouldn't add another hash. We would just expand the 32-bit crush hash to be bigger.
Okay.
So anyway, that's the core idea. The idea in its entirety is that basically you put the very very efficient fixed size portion to the left of the node, and you do whatever you need to do on the right side of the node to not waste space. It's okay if it's a little expensive because you're not going to look at it mostly. You won't look at it until you are actually going to need to compare strings anyway.
So in the optimal case, we don't need to look at the right side of the internal node.
Right, and mostly we won't store,
Okay.
we won't actually store strings there unless we need them to disambiguate pivot.
Or for listing or whatever, won't we need it?
I'm sorry, what's that?
For
Yeah.
reporting, listing.
By the time you get to a leaf, yes, the right side has to store the whole key, or the whole key. But again, we always have to do that. The entire
Okay, good.
sorry, except for the prefix, you still don't have to store the shared prefix part. That's actually just always free. But you do have to have enough stored to be able to reconstruct the full original key.
Sure. Okay, I get it.
Anyway, that's the core idea. Other than that, it behaves exactly like a B tree. You do splits and merges under the same conditions. There are places we could add complexity. We could allow the n equals 2 and n equals 3 or leaf nodes to be bigger than 4K, which would add some nuance to the exact size threshold rules. But even that's not really that complicated. It just changes the exact thresholds.
Okay.
So the things I like about this, Yingzhen, I can attempt to explain the multi-level design, but there's honestly a lot I don't totally get.
Oh, sure. That's no problem. But I think the core idea is the same. It's to, like I said, it's just to fix if the crash works correctly, we just need to compare string once and resolve the collision earlier before looking up the snapshot. I think that part is the same.
I mean, yeah, the design goal is the same. That's true. I guess what I don't get is what your design accomplishes that this one doesn't. I'm biased, I guess, in that I don't like the idea of nested trees because I think it will be harder to read and it will be less flexible. With this approach, we could actually introduce additional internal node encodings, even to existing stores. Wouldn't be backwards compatible, of course, but it would be forwards compatible. That would be much more difficult with the nested tree design because every time you add another nested tree, you add another level of underfilled root nodes.
Yeah,
so you can only do it so many times.
Yeah, the most complex part is a co-located logical tree, and I'm also not very certain about the actual impact it will have.
Yeah, that I don't really understand at all, to be honest. I will point out one observation I had. Generally speaking, it's not an unusual choice to take potentially large things that you store in a B tree and store them somewhere else. The problem is that if you choose to do that, you have two problems. One, you need to do an additional seek to find that value. But the big one for us, the part that's really going to make it hard, is you have to do allocation. If you keep it inside of the node, then the B tree split merge process automatically handles allocation and garbage collection for you. As nodes become too small, that is, they have too much unused space, you naturally merge them into their neighbors, and then you release the space. By contrast, if we choose to store the string somewhere else, we have to have a secondary system to do that allocation. Possible, but complicated.
Okay, but I'm not very agree with, because I think they are both, the allocation doesn't need to be very special. It's just to allocate like 4K blocks.
Right, that's incredibly expensive. That's the problem. We're already paying a high allocation overhead here. This is like allocating an O-node B tree node and mutating it will be probably the most expensive part of any write. So every additional mutation we add multiplies that by that factor. So no, actually, I think that just writing down where the node is will be the most expensive part of these operations. In other words, the LBA tree is going to be the most expensive part.
Okay.
So yeah, I'm really, really afraid of allocations. And I'm not talking about memory allocations, by the way. I'm talking about disk allocations. One way or another, we have to track which bits of disk space are used.
Yeah, I tend to agree, because if for example, if we need to move the old node from the logical B+ tree to the second level tree, there will be some disk allocations or movement, data movement.
Yeah, or worse, it wasn't obvious to me from your design, but as I understand it, the logical tree is rooted in the second from the leaf node, right?
Yes.
Okay, so we'll call that level n minus 1. So what happens when you do a split on level n minus 1?
Because the logical B+ tree is also ordered according to
the internal indexes, yeah.
Internal index, so the split will be, I guess it will
all
be,
of the nodes within.
It just split the middle, just like the middle part of the tree, to split the entire tree to 2 parts.
Right, but in general, that's at least 2 additional mutations, right?
Okay, yeah.
I think?
Yes.
Because there won't really be cases where it's only a single level. Especially in the common case where you don't have a lot of snapshots. In that case, almost everything will be stored in the logical tree, right?
Yeah, that's also why the tree size should be bounded if the all nodes of the same OID n space.
Yeah, it is bounded. It's just that it's going to be 2 levels.
That's why. Yeah.
It's just that it'll be 2 levels. It won't be 1 level.
Yes.
So in general, you'll have to split the root and also 1 child.
Yes, that's true.
Right. Anyway, so that's why I find that design to be complicated. We would need to write down exactly how much space overhead that is and how many additional IOs it causes on the average insertion. B trees have the property that this is sort of like a normal one that is. This is a well understood property. It's just logarithmic, right?
Yes.
Are you completely agree with Sam regarding to the?
Sorry, I just said yes, but is there any other questions?
I mean, are you good with the design proposed by Sam?
Yes,
or variants thereof. I think I was just trying to demonstrate that it's possible to do. I think it's very likely that we'll end up with something somewhat different, but I just wanted to demonstrate that we can get that property without literally having multiple trees. There is still, I think, more design work to do.
Yes, I think there's more leeway to do in the node level instead of as the tree level.
Yeah, it's more work in the node level. But the tree is integrate. It's just a single tree.
Yes, that will be whole easier than multiple tree.
Yeah.
Okay. So what do we think the next steps are?
Maybe you can start to prototype it as an in-memory B tree.
Yep, I think that's reasonable. I think if you want to get working on those soon, it's taking me forever to get the LDA tree part done because it's harder than I thought. So my suggestion is that you attempt to create an in-memory mock of the transaction manager interface. It'll be handy because it'll make unit tests easier anyway, so it's not wasted work. At least I don't think so.
Maybe the first thing is to understand the memory version, how how the operation, merge split operations looks like with this design, and then port it to the transactional interface of the.
Put in another way, I think the most important is to figure out the data structure and the operation, and instead of come up with the async version, we could come up with the synchronized version, which just skip the I/O, right?
Okay.
If you prefer to ship it up.
That seems reasonable.
Okay. Any comments or questions?
Yeah, no, that seems reasonable. Okay.
Cool.
Okay. So see you next week. And have a good one.
See you.
Later.
Bye.
Thank you. See you next week. Bye.
Bye.